Have you ever noticed that the world around us looks complex, but is actually built from simple shapes? Once you learn to break things down, you start seeing geometry everywhere. Hey, I'm Harsh from STEMstein Academy, and welcome back. Today, we're taking a closer look at composite shapes. Composite shapes are complex geometric figures composed of multiple simple shapes. So this can be 2D shapes or 3D shapes. We all know simple shapes. They're the ones that you've practiced your whole life throughout school. Stuff like squares, triangles, circles, spheres, cones, etc. We're going to take it to the next step and start combining these simple shapes to make even bigger, larger, more complex figures. In geometry, shapes not only have properties, they also have geometric formulas. In the case of 2D shapes, they have area and perimeter. Perimeter is the total distance around a 2D shape found as the combined length of its sides. So if we basically unfolded a 2D shape, its total length would be its perimeter, and this is measured in units. For example, if this rectangle was measured in centimeters, its perimeter would also just be centimeters. The second formula is area. Area is the amount of space a 2D shape covers, and its measurement is units squared. Let's take that same rectangle we talked about before, which was in centimeters. Its area would be in centimeters squared. In terms of perimeter, there is one major exception, and that's circles. Circles don't have sides. They just have one long continuous side. So to measure a circle's total perimeter, we actually call it circumference. And circumference relies on both radius, r, and pi. To calculate circumference, we use pi, which is a constant. For a number that is continuous, it would be 3.14. And circumference's actual calculation would be 2 pi times the radius, or just pi times the diameter, because diameter is just double radius. The reality is that area between a composite shape and its simple shape components actually stays the same. This is because the space that the triangle and the square cover separately is the same amount of space they would cover if they were combined. However, perimeter is something that decreases. And in this case, when we combine this square and this triangle, we actually have a side that is no longer exposed. So our only distance coverage would be 3 of these sides for the square and the 2 sides for the triangle. We're going to find its area. And to do that, we're going to know that its 2 shapes that it's made of are a rectangle and half a circle. So we got to find both those areas and add them together. Let's start with a rectangle. So the area of a rectangle is length times width. And in this case, it would be 6, which is the width, times 10. We know it's 10 because the length represents the diameter of that circle, which is double the radius. And we know the radius is 5. So when we equate those numbers, we get a total area of 60 centimeters squared. After that, we have to find the area of half the circle. But to do that, we got to find the full area. The full area of a circle is pi r squared, and r is 5. When we find out the values and evaluate it, we get a total area of 78.5 centimeters squared. Now it's a semicircle, so it's going to be half that. So our area is actually going to be 39.3. Now, to find the total area of the composite shape, we simply combine the 2 values we found, and we end up with 99.3 centimeters squared. With your newfound knowledge of composite shapes and how to apply past properties and formulas, I want you to try out this knowledge check word problem. Be careful about the components of this composite shape and how to apply those formulas of area and perimeter. Give it a shot and see if you can solve it. Thanks for watching this STEMstein Academy lesson. If you enjoyed, like, subscribe, and hit that notification bell. Also, comment down your answers to the knowledge check and any other science or math lessons you want us to do in the future. Remember, keep learning, keep exploring, and stay curious.